So, the first component that we will look at closely is the clutch plate. So, if we look at a clutch plate, we can immediately observe that it has friction material, okay, on it. So, we can see that this is the clutch plate. So, there are what are called splines for mounting the clutch plate on the gearbox input shaft. Okay. So, you can see that splines are like teeth like what to say projections on the inner surface, so that you can slide it on the corresponding splines on the input shaft to the gearbox, so that any rotation of the clutch plate is transmitted to the gearbox input shaft. So, we can see that this central hub of the clutch plate has a spline arrangement. Okay. We can also observe that a friction material is riveted on the periphery of the clutch plate. Okay. So, so this friction material enables the what to say pickup of torque from the flywheel when the clutch is engaged, when the clutch plate is initially pressed against the flywheel by the pressure plate. And we can also see these coil springs which are mounted here along the what to say along a circle, right. So, these coil springs are mounted in cavities, okay, in the what to say core of the clutch plate, and their main function is to ensure that they reduce torsional vibrations. Okay. So, they act as torsional springs. So, when the clutch is initially engaged, imagine that the clutch is in between my hands, the clutch plate. So, let us say this is the flywheel and this is the pressure plate. So, what is going to happen? The pressure plate is going to push the clutch plate against the flywheel. So, let us say the clutch is at rest, the clutch plate is at rest and the flywheel is rotating at some non-zero speed. So, suddenly there is a torque which is transmitted, right, and there is a speed differential. So, there can be some judder, right, due to the sudden pickup of torque. So, these coil springs serve to reduce the torsional vibrations that can result due to the engagement between the clutch plate and the flywheel. Okay. So, that is the role of the coil spring, and a similar mechanism is also provided along the axis. So, if you look at the a cut section of this clutch plate, you can see that the central plate of the clutch plate, when it goes to the friction material, has a shape which is like this. Okay, it is a thin plate, but it is pressed like this. Okay. Why do we think it is pressed like this? Because it cushions any sudden load that comes along the axis. So, imagine that the clutch plate is in between my hands. When I press the clutch plate, okay, in between the flywheel and the pressure plate, there is also going to be force along the axial direction, right. So, when I suddenly press it, there can be sudden shocks and vibrations along the axis. So, to reduce and absorb those forces, we have these cushion springs. They are not springs per se, that is they are not realized as typical coil springs, but then the clutch plate material itself has this shape along the periphery, so that the forces are absorbed, right, by these cushion springs. Okay. So yes. So, we look at this cut section. So, we can see that this material is like the blade of a fan. So, this comes from the, you can see this, what to say, these arms attached here, okay, to the central hub of the clutch plate. So, what happens is that, imagine that these are like some arms like this, okay. So, there are plates which essentially project from the hub and they are depressed like this, okay, very small depression, so that the force get cushioned. So, you can see one such thing here, okay. So, that is essentially attached to the core of the clutch plate, okay. Sorry. So, some main features of the clutch plate are that it is essentially situated between the flywheel and the pressure plate, okay. So, the splines on the clutch plate mesh with those on the input shaft to the gearbox, okay. And if we look at the springs, coil springs, these perform the role of torsional springs, okay. So, these are nothing but coil springs which are compressed in corresponding slots that are arranged tangentially, right. So, the main function of these springs is that they reduce the torsional vibrations. And similarly, the cushion spring okay. So, essentially reduce the sudden the effects of sudden engagement between the clutch plate and flywheel along the axial direction, okay. So, that is the role of this cushion spring. And typically these clutch friction linings are riveted on both sides of the clutch plate. Please note that the clutch plate, we can see that the friction material is riveted on both sides of the clutch plate. So, one side engages with the pressure plate, another side engages with the flywheel, okay. So, the friction linings are riveted on both sides of the clutch plate and commonly in most automotive applications, like vehicle applications, these friction linings are mainly organic linings, right. So, organic linings essentially consists of yarns which are made up of glass, aramid and cellulose fibers. Embedded in, so these fibers provide the structural strength, okay. They are embedded in a matrix of resins and fillers, okay. So, that is the typical lining which is used. So, there are metallic linings also used in some applications, off-road applications, okay, off-road vehicles, and in some applications, you know, like these organic linings are also realized as carbon linings, okay. So, carbon linings form a subgroup of these organic linings, and in carbon linings what happens is that, like, carbon fibers are introduced to increase stiffness of the lining material and temperature resistance. For example, they are used in race vehicles, you know, like where we need to engage and disengage, you know, very very frequently. So, and temperature resistance also becomes important, okay. So, these are the clutch linings per se, okay. So, that is the clutch plate. So, the clutch plate is pressed against the flywheel by the pressure plate. So, the pressure plate assembly essentially pushes the clutch plate against the flywheel. So, how is this pressure plate realized? Let us look at that. So, this is essentially a pressure plate assembly with a so called diaphragm spring, okay. So, this core is what is called as a diaphragm spring, okay. So, what happens is that these diaphragm springs have these so called fingers, okay. We can see these slender projections, slender metallic plates which are coming towards the center, and these fingers are pivoted above this pivot ring and then connected to the pressure plate on the other side. So, what happens is that, like, when we depress the clutch pedal, we are anyway going to apply a force on the center of the structure through the release bearing. So, when we apply a force which essentially acts on this finger acts like a pivot. So, when we apply a force like this, what is going to happen to this iron? It is going to be pulled up, but this end is connected to the pressure plate. So, what happens to the pressure plate? The pressure plate also moves up and the clutch plate is here, okay. So, when the diaphragm spring is pressed in this way, the pressure plate is moved away from the clutch plate by the spring action of these fingers. When the force is released, the motion happens in the opposite direction, right, and the pressure plate then pushes the clutch plate against the flywheel. Okay. So, this so called diaphragm spring is used to engage and disengage the clutch. Okay. So, that is what that is the role of this diaphragm spring and the pressure plate. Okay. And the actuation of these diaphragm springs takes place through by means of the release bearing. And what happens in when we engage the clutch pedal is the following. So, when we actuate the clutch pedal, there can be multiple what to say means. So, this clutch actuation can be mechanical, it can be hydraulic. Okay. So, please note that a good amount of force is needed to depress this diaphragm spring. Okay. A good amount of force needs to be applied on the release bearing to essentially disengage the clutch. And what is the source of this force? The human pedal input. Please note that a driver typically presses the clutch very what to say very frequently, right, while driving a car. So, imagine driving in city traffic, you know, like we have to press the clutch often. So, we need to provide enough mechanical advantage so that the force which is applied by the driver is sufficiently small and is magnified from the input to the release bearing such that the clutch is engaged and disengaged, right, appropriately. So, early clutch mechanisms used a purely mechanical action where we had cables and levers, and the magnification of the force was due to lever arm action. Okay. So, nowadays, you know, like in most clutches, you know, we use a hydraulic means of magnifying this force. So, when the driver presses the clutch pedal, so what happens is that, like, there is something called as a master cylinder in the clutch mechanism. When we come to brakes, we will see that there is a master cylinder in a hydraulic brake system, that is different. So, in this master cylinder, what happens is that this force is converted to a hydraulic pressure. Okay. And this pressure is transmitted through the fluid in the pipe, and that then goes to what is called as a slave cylinder, which is closer to the clutch assembly. Okay. So, the slave cylinder then actuates the clutch fork, and the clutch fork then goes and presses the release bearing, okay, and disengages the clutch. So, that is how the action of this hydraulic system works. So, the magnification of the driver's input force is done both by using lever action, because still even here there is a lever magnification, right, one here and another action here, right, there is a lever arm action, right, and by suitably adjusting the dimensions of the master and slave cylinders. right, because by suitably adjusting the sizes of the master and slave cylinders we can adjust the magnification obtained also, right. So that is how the clutch actuation takes place. So finally the torque which is transmitted by the clutch at steady state is given by following. So let us say the coefficient of friction of the clutch friction lining is mu, and let us say an axial force of F axial is applied, okay, because the pressure plate is pushing against this. So this is going to be the tangential friction force, right, the lump tangential friction force on the clutch plate, and let us say we lump all this force at a mean radius r, okay, of course the contact is over the face of the friction material. Let us say we lump all these forces at a mean radius and multiplied by n with where n is the number of what to say clutch faces, okay. So friction surfaces on the clutch plate. So this mu is the clutch lining friction coefficient. So typically around 0.3 to 0.45 for organic friction linings that are used. Okay. So F axial is the axial force applied on the clutch plate Rm is the mean or average radius used in this calculation. N indicates the number of friction surfaces. So N is typically 2 for a single plate clutch, okay, and if we have a multi-plate 2-plate clutch, right, N will be equal to 4, okay, and so on. So typically we use a multi-plate clutch when we want to transmit higher torques, okay. So that is when we use a multi-plate clutch, okay. For example, in heavy vehicles and so on, where we want to transmit more torque, we go for a multi-plate clutch, okay. So this is the this is a broad overview of the friction clutch which is used in the automotive powertrain. So just to go back to the layout of the powertrain. So in today's class we have looked at the clutch, okay. So tomorrow we will look at the gearbox, okay, which is downstream from the clutch in the powertrain. We will see how they are realized, what are its features and so on, and then we will look at how to put all these things together to match the specifications of the gearbox to the vehicle performance requirements, okay, given a particular engine. So that is something which we will do. So I will stop here for today. Thank you.